Hi, welcome to StatStuff. I'm Matt Hansen. This will be the first of a series of lessons that discuss the topic of process capability. In this lesson, I'll define what process capability is and introduce you to a method I like to use for calculating process capability, which we'll go over in more detail in later lessons. Now, there are no prerequisites for this lesson, so let's begin by defining what process capability is.
Well, as you might guess by the term, process capability refers to the measurement of how capable our process is at performing, and generally consists of a group of metrics that we'll use to view the process from different perspectives. So when we say process capability, it's also referring to as the voice of the process, or VOP. Now that term VOP is in contrast to VOC, which stands for voice of the customer and reflects the customer's requirements and expectations of the process. So why do we need to measure the process capability? Well, VOP is like the as-is snapshot of how the process is actually performing, the true performance it has. When comparing this to the customer's requirements, that is what the customer wants or expects, then the gap, those performance gaps between what the customer wants and where a process is actually performing, those become the project opportunities. So let's illustrate that a little bit. Let's say we've got a distribution here reflecting our actual process performance. Well, in the define phase, that's when we're trying to get the voice of the customer. That's like where the customers define for us their requirements, or the VOC. So they might say, here's their lower spec limit and here's their upper spec limit of where they're willing to say, this is what we want. This is our requirement and our expectation. Anything within this layer here is considered to be good. Anything outside of that is considered to be a defect. Well, in the measure phase, that's when we're trying to get the voice of the process, or we're trying to get the data for calculating the voice of the process. So it's within there that we're getting our data that's going to help us to determine the process capability, where the VOP is really saying, what are those outer limits of where a process is truly performing. And it's in the analyze phase that we try to analyze the gaps, where we're trying to analyze not only what the process capability is, but we're also trying to analyze now the performance gaps. Now that we know what the customer wants, we can see where we're actually performing, and the gap between the VOC and the VOP is really where we're seeing the root cause and the opportunity for us. So that's where in the improve phase we're trying to fix that gap now that we've identified it. In the control phase, whatever fix we have that we put into place to improve it, we want to sustain that fix.
Okay, now I'd like to show you a method that I like to use for calculating the process capability.
I think there is a basic method we can follow when we want to try to calculate the process capability. So here are a few steps I'm about to show you that involve some of the tools and some direction of which tools you might use when you want to calculate the process capability. So here's an overall view, and this will outline for us the next few steps and lessons that we'll be going over as we dig into this much deeper. First, it starts off with asking ourselves, what data is it that's being measured? Well, if it's continuous data that we're measuring, then the next question we want to ask ourselves is the process stable? Well, this is where we might use something like an IMR chart to help answer that. If we find that the process is not stable, then we need to stop. We cannot calculate the process capability. We need to try to fix or make some adjustments for whatever special causes might be found within the data that's making it appear like it's not stable. So if we do find, though, that the data is stable after all, then the third question we would ask ourselves is the data normal? And we would use something like a normality test to help figure that out. Well, if the data is normal, then we find ourselves using a capability analysis that's for normal type of data. And if we find that the data is not normal, then instead we would use capability analysis for non-normal data, like using a Box-Cox transformation. And if we go back to the first question, if we find that the data that we're measuring is actually discrete data after all, then instead we can just run a capability analysis. That's like for binomial type of data.
All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
I'd like you to identify at least two continuous metrics that are used within your organization. And what we want to use is these metrics for the next few lessons when we try to discuss process capability. Now, to your knowledge, for these metrics, has the process capability already been calculated for either one of those? If they have been, then what is the process capability for each one? Or do you or your organization consider each metric to be capable? If so, then how is that capability tested, and how do you validate that? If your organization were to find that those metrics were not capable after all, then what actions would be taken, if any? And what other critical metrics or processes could be affected if you find these metrics were not capable?
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.